Hi everyone. So let's continue with chapter 5 States of Matter, and we will go through the last subtopic, which is 5.4 phase diagram.
Phase is homogeneous part of a system that in contact with other parts of the system and they are separated by a distinct boundary. So ada pembahagi yang jelas between solid, liquid and gas. So for phase diagram, it is a pressure against temperature graph which are plotted at which equilibrium exists between the three states of substance.
So this is the phase diagram. It is a pressure against temperature graph, and in this graph you have all the three states: solid, liquid and gaseous state. So in this graph you can see at different temperature and pressure your substance will exist as what state. For the phase diagram, you have pressure against temperature, and there are three states of substance here: solid, liquid and vapor. So let's say you have three different conditions: condition 1, condition 2 and condition 3. So for condition 1, at certain pressure and temperature, it will exist as what? So we will look into detail. So at condition 1, at P1 and T1, your substance will exist as solid. So at condition 2, P2 and T2, your substance will exist as liquid. And next, at P3 and T3, your substance will exist as vapor. So this you can see at different pressure and temperature, your substance can exist in different states.
Next, we will look into detail what is critical point and triple point. So first we will look into triple point. So triple point is this part, this dot here. So it is a unique point where all the three lines that represent solid liquid boundary. So solid liquid boundary is this one. It's between solid and liquid. And liquid vapor, this line. Okay, so it is the solid liquid and liquid vapor boundary. And another one is solid vapor here. It is where all the three lines meets together. It is a unique combination of temperature and pressure where it can has three phases exist in equilibrium.
So critical point is a point that the maximum or the highest temperature the gas can be liquefied. So at this point, there are no boundary between liquid and gas phase. If beyond this point, above this point, it is impossible to liquefy a gas no matter how great the pressure applied to. Now let's look at the phase diagram for carbon dioxide. So you can see the line TA here. It represents the variation of sublimation temperature with pressure. So it called as sublimation because this is the phase boundary between solid and vapor. So you can see TB, T is the triple point. So with point B here, this boundary is between solid and liquid. So you can see a variation of melting temperature with pressure. And the next one is TC. So TC here is the boundary between liquid and vapor. So you can see variation of boiling temperature with pressure. So in this case, kenapa boiling? Because for boiling, it is from liquid state to vapor. So untuk melting process, melting it is from solid to liquid. Let's have a look at phase diagram of carbon dioxide. So you can see here for phase diagram for carbon dioxide, it is a typical pattern which is it has rightward sloping, or we call it as positive slope. So if you want to see the slope, you draw a straight line here, and if your slope is on the right hand side, it is a positive slope. And this slope is the boundary. TB line here is the boundary between solid and liquid. So from solid to liquid, it is a melting process. So means at different pressure, it will has different melting point. So for example, at this specific pressure, let's say it is 7 atm, so it will has a certain temperature for the melting point. Let's say here is negative 60. So if I go higher in the pressure, I increase the pressure, let's say here is 15 atm, so I will have higher melting point for this substance. So let's say here is negative 90. Okay, so just example lah, random number I give it to you. Right, so the triple point for carbon dioxide is negative 57 degree, and the pressure is around 5.2 atm. So you can see the triple point here is above the atmospheric pressure, which is here. So means beyond or above atmospheric pressure, your carbon dioxide will sublimes. So at this pressure, the liquid phase is not stable, therefore solid will sublimes to form vapor. Thus, solid carbon dioxide, we normally call it as dry ice because it doesn't go through liquid state in its phase transition at room pressure. So it will directly from solid, it sublimes into vapor to form vapor. Next is phase diagram of water. So this is the phase diagram. How does it look like? So you can see the differences is the slope here between triple point and the phase boundary between solid and liquid. It will slope to the left, so we call it as negative slope. So for water at 1 atm, okay, it is above the triple point. So perbezaannya dengan carbon dioxide tadi, your 1 atm is below here. But then untuk phase diagram of water, the atmospheric pressure is above triple point. And at 0 degrees Celsius, it is the melting point of water. And at 100 degrees Celsius, it is the boiling point of water. And the triple point is around here. And the critical point as shown in the diagram. Okay, untuk phase diagram of water, dia lain sikit daripada the typical trend of phase diagram. So you can see the slope here is the TB line, the boundary between solid and liquid. Okay, so you can see this line. It is negative slope. Dia sedikit condong ke bahagian kiri on the left hand side. And the melting, this means the melting point ataupun melting temperature decreases as we increase the pressure. So as kita increase in pressure, so ini 1 atm, contoh 2 atm, 3, 4, 5. So as we increase in pressure, the temperature here akan semakin kurang compared to 1 atm. It's here, 0 degree kan. So mungkinlah at 5 atm, it will be in negative temperature. For other chemical compounds, the melting temperature increases as we increase the pressure because they will have the typical trend of phase diagram ataupun in other words, they will have positive slope. Okay, hanya anomalous case, anomalous behavior for water sahaja. This is connected with the fact that ice is less dense than water. The molar volume decreases. Okay, so volume decreases when ice melts. Okay, so for boundary TA, it represents the variation of sublimation. Sama juga dengan phase diagram of carbon dioxide just now. It's when you have solid and it directly converted to vapor and vice versa lah. And if vapor to solid, it is called as deposition. So untuk this boundary TB, so for TB, it's from solid to liquid. It is a melting process. And if opposite way, it is a freezing process. Okay, so untuk boundary TC, it is between liquid and vapor. So from liquid to vapor, it is a vaporization process. And from vapor to liquid, it is a condensation. So at low temperature, under the atmospheric pressure, the stable phase is solid ice. At 1 atm, the temperature at which ice and water are at equilibrium is called as melting point. So it should be at 0 degrees Celsius or 273.15 Kelvin. You can see the line that's separating liquid from solid phase. This red line here, it is not vertical and it is, we call it as negative slope for water, phase diagram of water. So means that the transition from solid to liquid, it happens at different temperature and different pressure. So you can see this part at temperature between 0 degrees Celsius to 100 degrees Celsius here, and at 1 atm under atmospheric pressure, the stable phase of liquid, the stable phase of water is in liquid form. At 100 degrees Celsius, the line representing the equilibrium between, so 100 degree is around here, the line between liquid and gas is reached. The temperature at which boiling takes place under the atmospheric pressure is called as normal boiling point, and the boiling point also varies as pressure varies. Okay, so as you increase in pressure, the temperature will also increase, in this case lah, from the graph. So let's have a look at few cases. What if we increase the temperature but we kept the pressure constant? So at one fixed pressure, we increase the temperature from T1 to T2. It will cause the substance to, okay, so akan ada 3 point of your state untuk that substance. It will change from solid, and it will change from solid to liquid. You have T1 and T2. So between this T1 and T2, your substance will change from solid at point 1, and it will undergo melting process. So at point 1, your substance will exist as solid. At point 2 here, it is the boundary, phase boundary. So it will exist as solid liquid in equilibrium. And at point 3 here, your substance will exist as liquid. So let's have a look at point 1. So if you increase the pressure but at constant temperature from P1 to P2, so kita increase the pressure but temperature kept constant, it will cause the substance to change from vapor to liquid. So it is a condensation. So at point 1 here, the substance will exist as vapor. So at point 2, it will be in liquid vapor equilibrium because it lies on the line here on the phase boundary. So it will be in liquid vapor equilibrium. So at point 3 here, so at this point, your substance will exist as liquid. So you can see increasing the pressure, but if you kept the temperature constant, you will change the phase of your substance. Okay, sometimes the terms used, okay, isobaric. So isobaric ni maksudnya it inform you that the process happen at constant pressure. So ingat baric ni adalah from the wording of barometer. It's the thing that you use to measure pressure. So means ingatlah dia adalah constant pressure. So kalau isothermal, untuk isothermal here, so thermal adalah daripada perkataan untuk thermometer, temperature, thermal. And it is used to inform you that the process happen at constant temperature.